The search for alien life now. And this week, scientists attending the American Geophysical Union meeting in California heard about measurements made on Mars by a rover vehicle called Curiosity, which has been exploring the red planet for the last 2 years. What Curiosity has uncovered are organic molecules and also periodic puffs of methane gas, both of which might be signs that life is, or once was, present on Mars. So I spoke with the Open University's Professor of Planetary Science, David Rothery, to hear more about what these findings might mean.
Curiosity is the best rover there's ever been on Mars. It landed over 2 years ago now in a crater called Gale. It drove across some dry stream deposits. You can see structures in the rocks laid down by flowing water, and it's been sampling, working its way up the mountain called Mount Sharp in the middle of the crater, which is not the usual central peak you see in some impact craters. It's much bigger than that because we think Gale crater was buried by sediment which has then been partly eroded away. And this mountain in the middle, Mount Sharp, is a stack of sediment. So by climbing the mountain, Curiosity is getting younger and younger and younger in the stratigraphy. It will see how the Martian environment has changed over time.
And what sort of time scale does that cover?
Floor rocks in Gale crater are over 3.8 billion years old, so that is very old. That's more than 3/4 of the age of the planet. I should think the youngest deposits there are more than 2 billion years old.
And how is Curiosity sampling the rocks and the sediments it's seeing?
Well, by many techniques. You may have seen people with car bumper stickers saying my other vehicle zaps rocks on Mars, because it has a laser beam to fire at the rocks to stimulate some fluorescence and analyse composition that way. They also have a drill which gets centimetres below the very, very superoxidised surface to get some fresher material that have revealed organic molecules this week just gone at the American Geophysical Union meeting in San Francisco. And that's got people really excited that there are organic molecules inside Martian rocks.
What sort of organic molecules are they seeing, David, and why is this important?
The most complicated molecule they've got is basically benzene, which is a ring of 6 carbons bonded with hydrogen, with one of the hydrogens replaced by chlorine, so it's called chlorobenzene. There are some smaller molecules than that as well, but this 6-carbon ring, chlorobenzene, is the biggest one. Organic molecules are what you need to make living tissues, essentially, the building blocks of life. They found these organics in a sample called Cumberland, that was a few metres away from their other drill hole called John Klein, where there were almost no organics, so it's very, very patchy as well, and that's got people wondering.
Would the patchiness also be interesting? Because if it were just raining in from space, you wouldn't expect it to be aggregated in one place, whereas if something were concentrating it or producing it or using it, you might see more patchiness.
Yes, absolutely. You're quite right. The general slow rain of organics from space, unless it's patchily destroyed on the surface by processes we haven't got to grips with, would suggest that the organics have grown by some process below the surface, which makes people think, well, maybe there's a habitable environment down there, a habitable environment where some kind of microbes can live or did live in the past, because these are pretty ancient rocks. So you don't know whether it was life that was 3.8 billion years ago, or is it microbes living in the rocks today even? Because below the Martian surface, where you're protected from the horrible ultraviolet sunlight and extremely oxidizing conditions of the surface, to get below that, there are places where slow metabolizing, rock-gnawing, single-celled microbes could live, and these could be the traces of those creatures. It's far too early to say. Life has not been discovered on Mars, despite what people may have noticed in some of last week's newspaper headlines.
Now, what about other things that they're able to do with the rover? Are they finding any other molecules or substances that might lend weight to the fact that there are interesting processes happening that could have some kind of link to life?
Well, for quite a long time, people have been looking for methane, which is a molecule which can be produced as a byproduct of living processes. Methane doesn't survive long in a planetary atmosphere that's oxidizing. So finding methane in any abundance shows you the atmosphere's out of equilibrium and, hey, have we got life producing the methane?
And have they found some methane?
Yes, they have. And the excitement here is not just that they've got methane well above background levels, but it turns on quickly and turns off quickly.
And that would suggest then that it's being produced near to where the rover is? Because if it were being produced from a massive source and then spreading out across the whole planet, it wouldn't come and go like that, would it?
The signal would be blurred. The atmospheric mixing times on Mars are relatively short. So this is a local source. Where is the source? We don't know, but the winds blow from the north into Gale Crater. So somewhere north of Gale Crater, within 100 kilometres, something is emitting methane.
And how have planetary scientists like you received and reacted to this news?
Life has been discovered on Mars, in inverted commas, more than once before. So I think it's quite likely that microbes have once lived on Mars. Even if you can't start life on Mars, you can get life to Mars. If you hit the Earth with a big impact and blow some Earth rocks to space, they're going to have bugs in them, microbes, and some of those will rain down on Mars eventually. We've got bits of Mars that have fallen to Earth, so you can swap microbes between Earth and Mars. So I wouldn't be surprised if we find life on Mars, but if we ever do, we'll be excited to prove that there's life on another planetary body. Then the next step is, did that life begin on Mars or did it come from Earth?
David Rothery.